Today I got ghosted by HR, but it's okay. Let's still doing some LeetCode today. Today we are going to solve the problem number 402, remove k digits. In this problem, we are going to remove some digits, actually remove some characters from a string, which is a string of number. And we want to remove some characters, k characters, so that the results would be the smallest number after removing k's characters. Alright, so what are we gonna do? First of all, we want to make sure that in this case, we want the result should be in a increase order, so that it will become the smallest number, right? Because if you see this, take a look at this example. If it's 1 4 3 2 2 1 1 9. Oops, it's a little bit lagging off. Yeah. If we remove some character, let's say we remove 3 and 2, we want to remove three characters, right? Because the k is equal to 3. And in this case, we got 1 4 2 9. But okay, given these two strings, what we can tell? So it is the leftmost digits that would determine the superior of the two numbers. If the leftmost digit, let's say this 4 is greater than 1, it means the whole string number, the whole number would greater than the other, right? That's interesting. And with this, the first intuition we got for our problem is that we should iterate from the left to the right. And we should remove the digits from left to right. And the more a digit to the left-handed side, the more weight it carries. Now that we fixed on the order of the iteration, it is crucial to come up some criteria on how we eliminate digits in order to obtain the minimum value. So let's say we have here we have 4. Let me do this example, very simple example. It's the example 1. Given a string of digits, and if we are asked to remove just one digit, then from left to right we have the candidates as 1 4 3 2 2, right? You get the idea. And we compare each digit with the left neighbor. Starting from 4, here is the current pointer. And it is greater than its left neighbor. So we continue to move this pointer to the next. And now the left also move. So at this moment, we are sure that we should remove the digit 4 because the current which is 3 is greater, it's smaller, less than 4. The 4 is greater than 3. So we want to remove the greater left neighbor from the string, because the consequence of not doing so is that we won't obtain the minimum number no matter what we do subsequently. Imagine if we keep this 4, then all the possible solutions are lead with this 4, such as 1, 4, 2, 9, 1, 4, 3, 1. While in one of the opposite case, removing 4 and keep 3, we should have solutions lead with 3, which is something like 1, 3, 2, 9, 1, 3, 1, 9. And in either of these cases, we can see that if we keep the 3, it is always less than if we keep 4. This scenario of removing a digit as a row, as presented here, given a sequence of digit, here the digit, if the digit D2, we have D2 here, it's D2. And if it's less than its left neighbor D1, here's the D1, then we should remove the left neighbor in order to obtain the minimum result. Alright, this is the key to solve this problem, okay? So it clearly defines a condition on which we can remove a digit without a doubt. By removing the digits one by one, we're steadily approaching the optimal solution step by step. Now it might remind us it's actually called this algorithm called greedy, right? There could be some cases where the condition to apply the rule does not hold for any of digits. In those cases, we could have monadic increasing sequence, which is each digit is bigger than the previous digit. In this scenario, we simply remove the pending large digits greedily. We skip the rigorous two are the key point of solving this problem. And about this monotonic increasing sequence, we can easily think of the data structure stack, right? And so this is what we do now. So in this solution, we are going to iterate the sequence of digits from left to right, from left to right? And the main loop can be broken down as these steps. So for each digits, we want to append each we want to push each digits into the stack. And if we have visit, let's say, the first digit, we're gonna put this digit into the stack, and then we continue to the next digits, and we start to compare the first value of the stack to our current pointer's value. So here we want to see the first element of the stack if it is greater than our current value. So here 1 is not greater than 4, so we continue and we push this 4 into our stack, and our current pointer continue to move to next one. And now we can see that forgot to say that the first element of the stack is the current digit's left neighbor, right? It's so we can compare with our current digit. So in here, the 4 is greater than 3. So what we do now, we want to pop the pop from the stack. We want to pop this 4 out of this stack. So the 4 should be popped out, and 3 goes in because we have visited 3, and the iteration goes on to the next. Here 3 is greater than 2, so we should pop out this 3. Yes, and we push 2 into the stack. Oops, wrong color. 2 into the stack, and continue. We move to the next, and we can and along this way we should keep track of the case value, since we just have already experienced 2 pop out, right? So the k now it should be k now should be 1, right? And we continue to move to the next, and we pop another 2 into our push another 2 into our stack, and now we compare the first element of the stack to the current digits, which is 2 is greater than 1, so we should pop out this 2. This 2 should pop out, and we push 1 into stack. Ooh, it's 1, right? And we continue to move to the next, and now 1 is not greater than 9, so and this k equals to 0 now. So we push k into we push 9 into the stack. So after the iteration, we can see that here it's very it's just a coincidence we have the k equal to 0, but actually in many cases we have different situations. So let's consider different situations. Case 1, when we get out of the main loop, this is the main loop, we remove less than k digits, and in extreme case we would not remove any digit for the monotonic increasing sequence in the loop. Let's say that is we remove 0 digits. We remove 0 digits. K did not change at all after we have the iteration. In this case, we just need to remove additional digits from the tail of the sequence. For example, if we have after the iteration, we still have the number 1 to 9, and here the k still equals to 1. In that case, we should remove the last letter. We should remove the last digits. And this is one case. And we can consider another case, the second case. Which is if we remove all the k's digits from the sequence, there could be some leading 0 left. For example, in this example, the example 2 here. So this sequence is like this, and k is equal to 1. Obviously, we should remove the first digits, but what left us is this sequence. It's 0 to 0, 0. And to format the final number, we know we should get 200. In this case, we should strip the left zeros from this string, and luckily Python has function to deal with this strip string method. And we should consider another case, which is the third case, is we might end up moving all the numbers from the sequence, which means the length of this sorry, why I say sorry so many times. The length of number equals to k. That means after we pop all of these strings, the left string would just be none, and then it's empty string. Empty. And in this case, we should return 0. Okay. And next, I will go through the coding part. Start coding. So following the algorithm we talked earlier, we should use a data structure stack, right? So we initiate a stack, and we started to iterate the number, the input. So we have 4 digits in our input num. Here we have a while loop for pop the the top element of the stack. If the top of the stack is greater than our current number, we should pop that, because following the greedy algorithm, we should pop the leftmost as many as possible, right? So that leads to a smaller number in the result. So it should, while k still not equal to 0 and not 0, and we still have element in our stack, it's not to 0, and the top of the stack should greater than the current digit, and right, and in this case we should pop, and the k -1, and after all, we still need to push every digit into the stack. So we append the current digit, right? So after this iteration, we have to deal with a situation where we still have k left, k still greater than 0, which means we still need to remove more digits from this string. So what we do, as I mentioned earlier, we should remove the last part of the last k characters from the stack. So our stack become k. If k greater than 0, we update the stack. And finally, we can have a result string, which is we got all these elements in stack into the string, and we also should remove the leftmost zeros, right? And we actually can combine this method together. And finally, we return the result string if it's not empty, right? If length without string greater than 0, else we just return 0, which means if the result string is empty, we should return 0. Let's see if it works. Yes, it works. Okay. Thanks for watching. Bye.